Our first chapter is momentum, the chapter on momentum. Now this is a very short chapter. As you can see, it is actually only 5-6 pages long. It's not a very difficult chapter, but there is a few catches. Okay, so if you know where I can, or where the examiners can try to catch you, then you'll be fine. Right, so the first definition that you have there is the definition of momentum. What is the momentum? It's the product. Remember, when we say product, it's a multiplication of mass and velocity. So the product of mass and velocity. So the formula for momentum, the symbol is lowercase p, and that is m times v, mass times velocity. Mass is measured in kilograms, velocity is measured in meters per second. So then the unit for momentum is kilograms meters per second. Okay, so it's quite an easy unit to remember. It's kilograms times meters per second. Now, because velocity is a vector has size and direction. So because velocity is a vector, then momentum will also be a vector. Okay, so momentum is also has direction, and that is one place where they will try to catch you in an exam. Okay, so you need to remember to choose a positive direction, and that direction will be the same direction as the velocity of the object. Okay, so I gave an example in the video. I said, let's say you have two cars, A and B, and they're driving in opposite directions. The one has a velocity of 10 and the other one has a velocity of 10, and they both have a mass of 5. Will their momentum, mass times velocity, be the same? Yes or no? Why not? They're moving in opposite directions. So then the momentum will not be the same, and that's the trick question that they might ask you in an exam. Okay, let's look at a calculation. It tells you a car with a mass of 800 kilograms moves at 72 kilometers per hour. And I said, let's just add there to the right. Okay, because I didn't put that in there. What is its momentum? So the mass is 800 kilograms. The velocity is 72 kilometers per hour. We don't work in kilometers per hour. We work in meters per second. So you have to divide by 3.6 and you get 20. So mass times velocity, and it gives you 16,000. And this is in kilograms. This is in meters per second. So the unit is kilograms meters per second. And because the velocity was to the right, the momentum is to the right. Okay. Then the next thing is the change in momentum. Now, when will we have change in momentum? When we have a collision. So a collision is a car crash or a crash. So you have two objects and they collide with one another. Okay, then you'll have a change in momentum. Because this one had a momentum to the right, and then it crashes with that one. And now you can see it's going slower to the right, or stop for a moment. So when there's a collision, we will have, or an external force, we will have a change in momentum. Now change in, the symbol for change is triangle, that delta. And change in is always final minus initial. Okay, so the change in momentum will be the final momentum minus the initial momentum. And we have that when there's external forces present. And in grade 12, we're only going to look at straight line scenarios. Okay, so it tells you there. A ball of mass 500 grams is thrown at 20 meters per second at a wall and bounces back at the same velocity. Calculate the change in momentum. Now, I tell you there's two ways. I'm only going to show you one way because that formula is a formula that's on your data sheet. So I show you the one with the formula that you have. Okay, so if we look at the scenario here, this ball goes to the wall at 20 and it bounces back at 20. Now you can see there's a change in momentum and there's different directions. So that's why we need to first thing do is choose a direction to be positive. Now, the same as in your next chapter, if the ball moves to the right first, then we choose to the right to be positive. If the ball moves to the left first, then we will choose to the left to be positive. Okay, so because it moves to the right first, we choose to the right to be positive. They told us the mass is 500 grams, but we do not work in grams, we work in kilograms. So what do we need to do? We need to divide by 1,000. Okay, so that's how I got to 0.5 kilograms. The initial velocity is 20, and then the final velocity is negative 20. Why negative? Because it's in a negative direction. So that negative is important, negative 20. So if we go to our formula, the change in momentum is the final momentum minus the initial momentum. So it's 0.5. I just took out the mass because it's a common factor. I took that out. 0.5. The final velocity is negative 20. And the initial velocity is 20. So minus 20. And you get it to be negative 20. Are you allowed to leave your answer in the negative? No, no, no. So you write 20 kilogram meters per second. And because we chose to the right to be positive and our answer is left, it means it's to the left. Okay. Right, then the next one is impulse. The concept of impulse. Now, what is impulse? Impulse is the product, again the multiplication of, the product of the net force acting on an object and the time that the net force acts on the object. Okay, so the formula here is also a formula on your data sheet. Now, in this formula, F times delta T, that whole concept is impulse. Okay, so impulse is not the force, impulse is not the time, impulse is force multiplied by time. That is impulse. Okay, so impulse is equal to the change in momentum, and I'm going to explain why that is in a moment. Just quickly see, force is measured in newtons and time is measured in seconds. So the unit for impulse is newtons times seconds. So Newton seconds. Not newtons per second, because then it will be a -1. That's per. It's just Newton seconds. Okay, that's the unit for it. And that is equal to the change in momentum. Okay, now why is that? And this is what I did here at the bottom. You all know what this formula is about? Yes? What is it? Newtons? Okay. Yes. Yes? Right. Okay. Right. So this is Newton's second law. Okay. Now we know that acceleration is the change in velocity over the change in time. Or we can say it's the final velocity minus initial velocity over the change in time. Do you remember that from grade 10? Way back. Okay, so instead of writing acceleration, I can just write the change in velocity over the change in time. Okay, so I just took that, and instead of writing acceleration, I wrote that. Then I multiply that in there, and I took the time over to that side, so it becomes multiply. Okay, so we have F net multiplied by time gives you mass times the change in velocity, or that's the same as mass final minus mass velocity initial. And that is the same as the change in velocity. Okay, so that is how they got to the impulse formula. Okay, and from that, or due to that, or because of that, they want you to know this definition here. Okay, what is this definition? It's Newton's second law in terms of momentum. It says there the net force or the resultant force acting on an object is equal to the rate, and rate means divided by time. The rate of what? Of change in momentum. So divide by time, the change in momentum. Okay, of an object in the direction of the net force. So instead of saying Newton's second law, you can also just say the net force is equal to the rate of change of momentum. Okay, so they can ask this formula, or you must use this formula, or you must apply it in a theoretical scenario. Okay, and we will do an example like that on the next page. Then I also just want to say, in this formula, in both these formulas, that F and that F, okay, they say in the two definitions, they say it is the net force, but sometimes in a question in an exam, they ask you to calculate the average force. Okay, and then for now, they will be the same thing, the net force and the average force. I don't know why they do it like that, but they do it. Okay, let's look at an example there at the bottom. Way at the bottom, the last example. Okay, it says there, a cricket ball of mass 0.2 kilograms is moving at 30 meters per second. Calculate the average. So here you can see they ask for the average. The average force exerted by the wicketkeeper if he stops the ball in 0.3 seconds. Okay, so you can see at the bottom of my page I put 2. Sy sê sy's by die hek. Ek sien haar nie. Dalk is sy by die ander hek. Okay. So, they ask for the average force. So that's why I put a question mark there. The final velocity is 0. Why is the final velocity 0? If he stops the ball. Okay, so final velocity is 0. They say the time is 0.3 seconds. The initial velocity is 30 and the mass is 0.2 kilograms. Okay, now if you just look at the example here. The ball is coming here. Okay, and it's moving at 30. What must I do if I look at my picture before I start my question? What must I remember to do? Choose the direction to be positive. So because the ball is moving to the left first, I choose to the left to be positive. Okay, so that's why I chose to the left to be positive. Then I also wanted to say another thing. Have you ever watched cricket? Yes? Okay. Princess, please show me. Do you know where does the wicket keeper, where does he stand in cricket? Yes. So we have a bowler, a batsman, a wicketkeeper, and field players. Right. So the bowler bowls. This way, and then we have the batsman, and in this scenario, the batsman misses the ball, and the wicketkeeper standing behind him catches it. Okay. And when he catches the ball, what does he do with his hands? He goes like this. What does he do then? What does he not catch the ball like this or just like this? What does he do with this? So that he can? You can get a sweetie. Did you get it right? Yes? Okay, boy, well done. Okay, so the force, or in more grade 12 words, the momentum is too much. Okay, it's going too fast. So what does he do? When he does this, is he lengthens the time for the ball to come to rest. So if you so it's the same as when you jump. Okay, when I jump, I don't jump with straighties. I don't go. Oh, I can't even jump with straighties. I don't go. Okay, it will be too short, right? What do we do when we jump? We bend our knees. Okay, why do we do that? We lengthen the time for us to come to rest. Okay, it takes longer to stop, but it decreases the force on our joints. The same thing when you catch the ball, it lengthens before it comes to rest, but it just makes the impact less. Okay, right. That's all that I wanted to say there. So, you see why this is positive 30, because we chose to the left to be positive. We start with our impulse formula. Okay, and then you can see I just elongated it. So final velocity minus initial velocity. So then we have time is 0.3 seconds. The mass is 0.2. Het jy al gekry? Dankie. 0.2. Sê weer? Ja, dankie. Hello. Just wait your notes. Hi, Mama. You need to get yourself home. All right. Okay. The mass is 0.2, the final velocity is 0, and the initial velocity is 30. Remember in grade 12, you need to put in your zeros. Okay, you can't just leave it open. You need to put in your zeros. And if you calculate that, you get a negative answer. You're not allowed to leave your answer in the negative. So it's positive 20 newtons. And because we chose to the left to be positive, and our answer is negative, it's to the right. Okay, now I want to ask you, and this is a question for a sweetie. We have calculated that the force is to the right. That's right? But he does this with his hands. He's taking his hands to the left. How is the force to the right? He's taking his hands to the left. Getting our hands. Say again? Did we make a mistake in our calculation? We calculated the force is going to the right, but it catches the ball like this. Okay. If the force was to the, so let's look at a force diagram or scenarios. He catches the ball. The ball is moving to the left. If the force is to the left, will the ball stop? So if he is catching the ball is coming from here, so this is my ball. Okay, the ball is coming. If the force that he applies on the ball is to the left, he will be throwing the ball in that direction. He's not, he's stopping the ball. So what is happening is as he catches the ball, he's actually exerting a force on the ball in that direction for the ball to come to a stop. Okay, that's why your muscles are all involved. Okay, so even though it's moving to the left, the force is still applied to the right. Okay, then the next question is another ball. So now the bowler bowls another ball. It comes in again at 30 meters per second. But now the batsman hits the ball. So it asks, how long will the ball be in contact with the batsman's bat if he hits the ball back to the bowler with a force of 100 newtons and a velocity of 20 meters per second? Okay, so what's happening here is the ball comes in at 30 and he hits the ball back. Now I know when a batsman hits the ball back, it will go up or left or right or whatever. But in grade 12, we're just doing it in a straight line. So the ball is coming here and he hits the ball back there. Okay, so he hits the ball directly back, and they say it has a velocity of 20 meters per second. So there we have 20 meters per second. And because we chose, at the beginning of the question, we chose the left to be positive, we stick with that. You don't change it. You stick with to the left as positive. So now he hits the ball to the right, so now it's negative 20. Okay, when he hits the ball to the right. So that is why it's a negative 100 the force. Okay, so not positive. Okay, just the B will leave you if you leave the B. Okay, so again we're going to use the same impulse formula. Force delta T is equal to delta P. The force is a negative 100. We're going to calculate the time. The mass is 0.2. The final velocity is negative 20. And the initial velocity was 30. And that's why you get 0.1 second. if for some reason you forgot to make this a negative or this a negative, your time will be negative. Are you allowed to have a negative time? No, you can't go back in time. Okay, right, then I left out question 3. We go to question 4. Now this is where I said that Newton's second law of business. Now this is a good, I said here, multiple choice question, but nowadays they also ask it quite often as a longer question, a longer theoretical question for 4 or 5 marks. 3, 4 marks. Okay. So they say there, a vehicle is the tree and the front of the car crumbles 1.5 meter until it comes to a stop. Explain why this is better for the driver if the front end of the car crumbles during the collision by referring to relevant formula. Alright. Now, if they say something like this, by relevant formula, or if they say by referring to a scientific principle, or referring to a law or whatever, then you have to mention that law. You have to mention the formula. You get a mark for doing it. Okay, so you actually get a mark for saying, alright, now we're going to look at the impulse formula. You get a mark for doing that. Now, when they ask, explain why it is better for the driver, then we are looking at the force. What impact will we have on the driver? Will he hit his head against the front of the car, or will the seatbelt just slightly pull him back? Why is it better for the driver? So they're basically asking you, look at the force, calculate the force. Okay. So we want to do that. So that is why I took my impulse formula and I rearranged it so that I just get F as the topic or the object of the formula. Okay, so I took the T out, so it's the change in momentum over the change in time. Okay, and that is Newton's second law in terms of momentum. So they can also ask by referring to Newton's second law in terms of momentum. So then it's that one there. Okay, so I have to look at both of these things because both will have an effect on the force. So I first looked at the change in momentum. So because it's at the top of the fraction, it is directly proportional to. So it means as the change in momentum goes up, the force will go up. Or as it goes down, the force will go down, right? So what is change in momentum? It is the mass times the final velocity minus the initial velocity. Now, when this car crashes, at the end, the velocity, so at the end, the velocity will be 0. Before the car crashed, the velocity would have been 100 kilometers per hour or 50 kilometers per hour or whatever it is. Okay. So at the end, it will be 0, and at the beginning, at the end, it will be 0. At the beginning, it will be 100. Okay, so it doesn't matter if it takes the car 10 seconds to crash or 10 minutes to crash. Okay, the beginning and the end velocity will be the same. And in grade 12, we're going to accept that the mass will remain constant. Okay, so the crash is not that big that a tire flies and a window falls out and whatever. So the mass of the car remains the same. So if this is the same, this is the same, and this is the same, then because delta P remains constant, it will have no effect on the force. Okay, so now I'm going to look at the time. Now because the time is below the fraction, it is inversely proportional. What does that mean? If the time increases, the velocity, the force decreases. Okay. Now, when the car crumbles, what happens is it doesn't just boing and come to a stop. In the car crumbles before it stops. So the time increases before it stops. I'm going to use this example again. So if it just stops, then the time is very short. But if you bend your knees, it increases the time, but it makes the force less. So when a car crumbles, the time increases, and thus the force decreases. And that's why it's better if the front end of the car crumbles. Okay, good longer question, but we're going to practice that later again today. Then we're going to look at the second last concept. First, we're going to look at an isolated system. So, in all the question papers and memos, they use the word closed. But please don't use the word closed. Okay, they don't want it anymore. They only want isolated. So, if you see closed, don't use it. Isolated. What is an isolated system? An isolated system is one in which the net external force, so all the external forces added together on the system, is 0. So basically, it doesn't have an effect. Okay, what is external forces? Applied force, frictional force, air resistance, stuff like that. Okay, so for you, the wording will actually be ignore the effects of friction. When they say that, or there's no friction present, then you know it is an isolated system. Okay, so we're going to use this isolated system with the concept of the conservation of linear momentum. Right, so what does the word conservation mean again? It means to keep constant, to keep protected, to keep the same. So don't change. And linear means in a straight line. So the momentum in a straight line is kept constant. Conservation of linear momentum. Momentum in a straight line is kept constant. Okay, what is that conservation of linear momentum? The definition is the total. Total means adding together. The total or the adding together of linear momentum of an isolated system remains constant or remains conserved. Okay, so that just means that we're going to look at a perfect scenario where if two things collide, so this one is stationary and this one collides with that one, then the momentum together at the end will be the same as the momentum at the beginning. So if this was stationary and this had a momentum of 10, and afterwards they go together, now each has a momentum of 5. Because 5 plus 5 is equal to 10 plus 0. Okay, so it means everything has to be constant from beginning to end. Nothing is lost. Okay, now where will we use this principle? When we have a collision. Okay, when something collides, but a collision is not necessarily just a car crash. It can be if I am here and I push him, that's a collision. Okay, or if I stand on a skateboard and I step off, there was a force. So collision in your head must be almost when there's a force being exerted. A force causes a change. Okay, now the formula that goes with this principle is, this symbol is called sigma. And sigma means the sum of, or the adding together. So the sum of the momentum at the beginning is equal to the sum of the momentum at the end. Okay, sum of meaning all the objects together, add them together, all the objects together at the end. Okay, and then it says remember to choose directions. So let's quickly look at the scenario here. They tell you have a ball moving to the right at 25, with a mass of 25 moving at 20 meters per second, and a ball with mass of 10 moving at 10 meters per second. Here I made a mistake there. That 10 must be 10 kilograms, not 10 grams. Okay. Alright. Then, because this ball is bigger and it's moving faster, obviously it will catch this ball and it comes and it collides with them and then move to the right afterwards. So we have a collision, and then in your head goes bing, 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 conservation of linear momentum. We have a collision, and then after the collision, the 25 moves at 15 and the 10, we don't know what's the velocity. So we are going to calculate that. Okay, you can see they are moving to the right. So what am I going to do? I'm going to choose right to be positive. Okay, so here I have the sum of the momentum at the beginning. How did I know I must use this formula? Because there was a collision. Okay, sum of the momentum at the beginning is equal to the sum of the momentum at the end. That is, so what is momentum? It's mass times velocity. And sum means adding together. So we're going to look at this and this one at the beginning, and this one at the end. So we have 2 things at the beginning, 2 things at the end. Okay, the mass there is 25, and the velocity is plus 20 because it's moving to the right. So 25 times 20, and this one is 10 times 10. Okay, so at the beginning, then at the end, I have 25 times 15, and then I have 10 times I don't know what. Okay, and then I calculated it on both sides, and I simplified, and I get 22.5 meters per second to the right. Okay, where will you get your marks for the formula, one of these 2 formulas? For substituting the correct values on each side, and then for your answer you might get a mark for the answer and the direction, or just 1 mark for both of them correct. Please do not forget your directions. Something I wanted to say. Oh, this formula here is not on your data sheet. So not on the data sheet. So please, 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 please memorize it. Know when to use it. Okay, let's look at the second example. It tells you there we have a ball of mass 2 moving at 10 meters per second and one of 4 moving at 20 meters per second. Now they're moving in opposite directions. They say it collides head on. Head on means in opposite directions. Okay, collides head on. They stick together after impact. Calculate the final velocity. So they collide, obviously, because in opposite directions, and then they stick together, they become one thing, and then we don't know is it moving to the right or to the left, we don't know. Okay, so we must calculate that. How do I know? I must use the conservation of linear momentum because there was a collision. Can someone try to give me the law of conservation of linear momentum in words? Starts with the total. Don't look on your note. Yes, Mama? Near. Princess? Mooi job. Okay. Will you be able to say that? Okay. Alright. So, they go in opposite directions. What must I remember to do? Choose a positive direction. Now, you can really choose anyone. One will give you a negative answer, one will give you a positive answer, but at the end you write it as positive. So, it will give the same answer. But my gut feeling tells me this one is bigger and it has a bigger mass. So, its momentum will be bigger. It will have a bigger impact. And it's moving to the left. That's why I'm choosing to the left to be positive. Okay. So, that is why here, when I substitute in the values, I have 2 and then a negative 10 because it's moving to the right and we chose to the left to be positive. Then we have 4 times 20. And on the right-hand side, I wrote this down as one thing. Why? Because they stick together. So they will have the same velocity. I can see it as one thing. So the mass of this one thing is 2 plus 4. 2 plus 4. And I don't know what the final velocity will be. Okay, you substitute it and you get 10 meters per second. And because you get a positive answer and we chose to the left to be positive, it is to the left. Okay, then here's the next one. It says a bullet of mass 0.05 kilograms is fired at 280 meters per second. Determine the recoil velocity of the gun if the gun has a mass of 7 kilograms. What is recoil velocity? What happens when you shoot a gun? Especially a big gun like this, a machine gun. Yes, it kicks back. Princess, how do you know that? Oh, movies. Alright, so when you shoot the gun, because of the force that the gun exerts on the bullet exerts the same force on the gun back on the shoulder. Okay, whose law is that? The force of the gun on the bullet on the gun. Okay, can someone tell me Newton's third law in words? Yo, Princess, on it. Yes, Jabu? Yeah. Girl, did you study this holiday? So it's just all there. So why don't you do better in science then? Huh? If you can remember it like that. Anyway. Alright, so why did I ask this? I didn't just ask this because I remembered this. This law, Newton's law, they ask a lot in this chapter. Okay? Because it has to do with impulse and force and time and whatever. So you need to know that force, if the two objects collide, the force that the one exerts on the other is the same as the other on the one. Okay. So let's just look at the scenario here. Here the bullet is inside the gun and they are stationary. So the velocity is 0. And then you fire the gun. What happens? The bullet goes out at 280 meters per second. And we do not know what is the velocity of the gun pushing back. Okay, so it has a velocity, but we don't know what it is. The mass of the bullet is 0.05 and the mass of the gun is 7 kilograms. Okay, so because there's an explosion, a collision, a force, we use the law of conservation of linear momentum. Anyone want to try to say it? Law of conservation of linear momentum? Anyone except Jabu? Yes, Mosi. Mooi. Just that first of shouldn't be there, but other than that, good. Right. So at the beginning, the bullet was inside the gun. So it's considered one thing. They were together. So that's why I have one thing here. Okay, I don't have two calculations. I just have one. The mass of them together. And the velocity is 0. So it's basically 0. Then at the end, I have the gun. So that G stands for gun. The 7, the mass, times the velocity of the gun, I don't know, plus the mass of the bullet, times the velocity of the bullet. Okay, yes? No, they will tell you object A, object B, or stuff like that. What did I want to do now? Oh, what did I forget to, I did do it here, but what did I forget to say? Direction. Okay, now I just said your 280 meters per second is very fast. Okay, and it's going to the right, so I'm going to choose to the right to be positive. But if you chose to the left to be positive, you should get the same answer. Alright, so that's why it's positive 280, and you put in your values, and I get a negative answer, -2, not allowed to leave it in the negative, so that is 2 meters per second, and because I chose to the right to be positive, it is to the left. And it makes sense because the gun pushes to the left. Alright. Now I want to go to page 3. Okay. So this is a question that comes straight from a question paper a long time ago. And I want to do it because it's difficult, sort of. And because there is a mistake in the question. Because we have common sense, but I want to show you how they ask the questions. It says A and B are two wooden blocks suspended on thin cables. A bullet passes through A and is embedded in B. What in the world does embedded mean? Newton's second law is embedded in your brains. Stuck. It is there forever and ever. Yes? Until the day that you die, you'll remember Newton's second law. Okay, so embedded, so it sits in B. As a result of this, A moves at 6 meters per second and B at 4 meters per second. I see there is a negative missing. Anyway. Right, so let's just look here. So what happens is this bullet goes through A. So there's one collision. And then the bullet sits inside B. Because of that, the two blocks now swing because of that force. Okay. Now, what does your common sense tell you? When this bullet goes through A, what do you think will happen to A? It will have a hole in it, it will break. Okay, so the mass will change. But we, in grade 12, is going to assume that the mass doesn't change. And that is the mistake in the question. Our common sense tells us the mass must change, but we're going to assume now it doesn't change. Okay, unless they clearly state in the exam, the mass now goes to blah, 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 blah. But if they don't say anything like that, you assume the mass remains constant. Okay. Right, so we have two collisions, so we have two scenarios. So I'm just going to split this up here. I have scenario 1 and I have scenario 2. So in scenario 1, I have the mass of A, and I have, now I'm going to call the bullet, I'm going to call C because I have a block B. I don't want to be bullet B, and then I have two B's. And I have the mass of C. Then I have the initial velocity of A, the initial velocity of C, final velocity of A, final velocity of C. Because I have before they collide and after they collided. For scenario 2, I have the mass of B, mass of C. Initial velocity of B, initial velocity of C, final velocity of B, final velocity of C. Tot ziens. Sa my hand lê. Did you learn something today? Good. All right. So the mass of A is 2, the mass of C is 0.1. The velocity of A, before the bullet goes inside of A, do we have the velocity? The block was there before the bullet goes into him. What's the velocity? It's? It's 0, it's stationary, just hanging there. The initial velocity of C of the bullet, we don't know, and I'm going to make that Y. The final velocity of A, they tell us there, A moves at 6. So after the bullet has passes through, whatever, it's 6. And the final velocity of the bullet, after the bullet has passed through A, we don't know. It's not 6, it's not inside the block. I'm going to make that X. Okay, if we look at scenario 2, the mass of B, we have that as 6.4. The mass of C of the bullet is 0.1. The initial velocity of B, what is that? 6. No. Huh? 0. Before the bullet comes into it, it's just hanging. 0. The final velocity of C, the bullet, before it goes into block B, do we know what that is? No, I'm going to leave that open for a moment. The final velocity of B is what? 4. They tell us B moves at 4. What is the final velocity of the bullet? If the bullet has passed through and the bullet is stuck now inside B and B is swinging, what is the velocity of the bullet? Block, bullet inside the block. It's 4. Okay, it's 4 meters per second. Right, now just quickly look here. If the bullet passes through here, and let's say the velocity of the bullet here is 100. What will say that is after it has passed through A, so the final velocity of C. What will be the velocity of C before it goes into B? What will the velocity be there? 100. So the final velocity here is the initial velocity there. Okay, so that is X. Hallo julle. Julle kan. Julle gaan net moet stil sit terwyl ek gou die som verduidelik. Die sitplek hier voor oop hoor. Alright, so hulle was net 'n les agter, so ek maak net gou hierdie les met hulle klaar. Right. So they ask that A, what is the velocity of the bullet between A and B? So they want the velocity there. So we can either look at the first scenario and get the final velocity of it, or we can look at the second scenario and look at the initial velocity. Which one will be a better option? Why? It has more information, so we're going to look at the second scenario. Okay, so I'm going to say consider the second scenario. Okay, and because there was a collision, we are going to use the law of conservation of linear momentum for a sweetie. Law of conservation of linear momentum. Yes, Mosi? Okay, good. So, the total means the sum of, so sigma, the momentum at the beginning, is equal to the momentum at the end. There was two objects. You saw? We remember we're looking at scenario 2. There were two objects, the bullet and the block, and then afterwards there was one object, the bullet inside the block. So here we have mass times velocity of C plus mass times velocity of B at the beginning is equal to mass of C and B times the final velocity. Okay. So the mass of C is 0.1. The initial velocity of the bullet we don't know, so it's unknown. Plus 6.4 times 0, because at the beginning the block was stationary. Then the mass we have here is 6.4 plus 0.1, because the bullet is inside the block. And the velocity was 4. Ooh, what did I forget to do? Okay, now everything is just moving to the right, so I'm going to choose to the right to be positive. Okay, and then if you calculate that, what do you get? Oh, Moshi, did I give you this? Yeah. You get what? Yeah. 68. What did you have? That is 0. Okay, 260. And because you get a positive answer, and because we chose to the right to be positive, it is to the right. Okay, and then they ask you what is the velocity of the bullet before it strikes 1. So now we're going to look at the first scenario. So we're going to say consider scenario 1. Again, there was a collision. So again, and here we have the bullet and block A, and then again bullet and block A. So it's 2 and 2. Afrikaanse kinders, het ek vir julle die memo gewys aan hierdie. Julle moes dit mos gedoen het. En nie die tweede ene nie. Is dit nie hierdie nie. Ek nog het gefreeze en to unfreeze. Het was dit gemerk. Okay, so the mass of C is 0.1. And the velocity we don't know. The bullet is 2, the velocity is 0. And then we have 0.1, and we just calculated the velocity to be 260 at the end, so it's 260. And 2 times 6.4? 6? Just 6. 6 or 6.4? 6. Okay, going. What did you get? 380? 380 meters per second. And because we chose to the right to be positive, and because our answer is positive, it means that's to the right. And then does it make sense that here the velocity is 380 and here the velocity is 260? Does it make sense that it slows down after you pass through block A? Yes. Okay, so you think you're more or less on the right path. Alright, nou is ons allemaal op dieselfde bladsy.